Hey, what do you call a dinosaur with an extensive vocabulary? A thesaurus. Ha. We're going to talk today about infinite solutions. So this lesson, we're talking about the different kinds of solutions you can end up with for equations when you solve equations. And infinite means, without limit. It goes on forever and ever and ever. Your I can statement is to simplify an equation into the form A equals A and recognize that infinite solutions exist. So up until now, you may not have known that you could have infinite solutions. We're going to review some single solution equations so we kind of know what we're talking about and then get into the infinite. All right, your number clue is going to start us out here. It's a multiple of 3 minus 1. So that's the next number clue. It's a multiple of 3 minus 1. And I think this is the start of a new number, if I'm not mistaken. Yeah, the last number was 16, if you had figured that out from all the clues. So this is the start of a new number. All right, guys, single solution equations. Remember how we solve these equations. We would, subtract 5 from both sides. So I'm looking at this equation right here, x plus 5 equals 25. We got rid of the 5, and we found that x equals 20. So because of the way this equation worked out, there's only one possible solution for the variable that made this equation a true statement. So we say there's only one solution, because the only way that we can make this equation true is if x is 20, okay? But there are some equations where there's way more than one solution. So let's look at those. All right, because you can end up with something that looks like this, because you can end up with a number equals a number, or even x equals x, this would work for every imaginable value of x. So if x was 3, it'd be 3 equals 3. If x was 2, it'd be 2 equals 2. Because of this, we see that there's an infinite amount of solutions, an infinite, or x could be all real numbers. And one way we write that is x equals, and we put this fancy looking r. Let me try and write that a little better. Kind of like 2 lines for the vertical part of the letter and then an r. So that would mean that x is any real number. Okay, so this is, if our equation comes down to a number equals a number and it's a true statement, we know that there's an infinite number of possibilities for x. Let's look at an example. All right, so you're going to be given problems going to say, tell how many solutions exist. So maybe there's only one solution. Maybe there's only one solution. Maybe there's an infinite amount of solutions, okay? Infinite solutions. And in the next video, not in this video, we're going to look at equations where there's no solution. So these are the possibilities, I guess you could say, for solutions. And we have already learned this one, and we're learning about this one right now. So when we have an equation like this, we begin simplifying. Notice there's an x on both sides of the equal sign. So we have to know how to attack these. What should we do? Well, we should begin by simplifying like terms. So the first step I'm going to write here is begin by combining. This is for both sides of the equal sign. Combine, or I should say combine, not combining. Combine like terms, okay? It's the first thing we're going to do. You might want to write that down. Combine like terms. And how's it going to look? Well, this is going to be 2x plus 1. There's nothing on the left-hand side to combine, but this is going to be 2x plus 1 on the right-hand side because 3 minus 2 is 1. Now, already we should be able to determine, hey, there's going to be an infinite set of solutions here because I've got exactly the same thing on the left-hand side that I do on the right-hand side. So no matter what x is, it's always going to equal itself. But I want to show you how to, take this one step further, because you might need to do this in the future. So the second step I'd like you to do is move all the variables to one side. So in this case, I want to move this 2x over here, okay? And how would I move a 2x over? How would I get 2x to 0 on the right-hand side? Well, I'd subtract 2x from both sides. And look what happens. I end up with 0 here plus 1 equaling 0 plus 1, or 1 equals 1. So if I'm going to take a step back here, we ended up with an equation that looks like x equals x, or back here, an equation where a equals a, so of the form a equals a, where a number equals a number, or x equals x. So we have something that equals itself. And because of this, whenever you get this, we know that infinite solutions exist. Okay? Infinite solutions, because we have the same thing equal to itself. All right, let's do one more real quick. All right. So I'm going to change my color here. So again, I'm going to combine like terms. I have 4x minus 5. I can't combine any of those terms on the left-hand side. I'm going to distribute this, so 4x minus 2 minus 3, because I distributed 2 to both terms here, right? We learned about that already. So 4x minus 5 equals, now I'm going to combine terms, 4x minus 5. So immediately, because you have the same thing on both sides of the equal sign, you say infinite solutions exist. Okay, so that's really all there is to this. But I just want to point out one more thing. If you wanted to get it down to where, if you wanted to see that x equaled x to know for sure there's infinite solutions, look what you could do. You could see in the last example, let's see if the page will go back. I subtracted 2x from both sides and got 1 equals 1. Well, in this time, I want to show you how you could approach this a different way. I could add 5 to both sides, and the 5s would go away, and I would end up with 4x, these went away, equals 4x. And then if I divided by 4 on both sides, I would end up with x equals x. Whoops, not a. X equals x. I don't know why I wrote a. And because of that, we again know it's infinite solutions. But notice in this example, I got rid of the numbers and left x. In the last example, I got rid of x's. It doesn't matter which one you get rid of. If you end up with something equaling itself, infinite solutions. One more quick example here. Tell how many solutions exist for this variable. Well, let's just see. Let's see if we come out with something here. So I've got 5x, because you're going to have problems like this, plus 14 equals 74 plus x. There's nothing to combine on both sides. I have no like terms to combine over here and no like terms to combine over here. So obviously, we're not going to end up with infinite solutions because the same thing isn't on both sides. But I still want you to know how to solve these for x because you're going to have problems like this. So in this situation, you want to remember that the first step was to combine like terms. It's already done. So combine like terms. We don't have to do that because all the like terms are kind of combined on each side of the equal sign. Second step would be to get all the variables or move all the variables to one side, right? Or move the variable, I should say, because there's only one variable, x. Move the variable to one side. Okay, so I'm going to start out by subtracting x from both sides. Okay, so this gets me to 0, so I have equals 74. These canceled out. And I have 4x plus 14. And now it's just a normal two-step equation. I'm going to change colors here. I'm going to subtract 14 from both sides now to solve for x. Okay, so now I'm left with 4x, these canceled, equals 60. And I divide both sides by 4, and I end up with, I'm going to move over here, x equals, these cancel out. It looks like x equals 15. So in this particular case, only one solution exists, only one solution, and it's x equals 15. And we knew that from the start because we had something different on the right-hand side than we did on the left-hand side. So if you come across this, it says, tell how many solutions exist for the variable. Well, only one does. One solution exists. But if only one solution exists, always tell what that solution is. Okay? You're going to do great with this. Good luck.